Thank you for your patience, although I'm sure you don't know that much. So on Monday, we started the rules of exponents. And first rule we came up with, anything to the 0 power is 1, except for 0 to the 0 power. It's undefined. So that was the first thing we did on our rules that we covered on Monday. And then we did x to some negative power is 1 over that to the positive. And then if we had a negative in the denominator, you can move it up to the numerator. And we dealt with negative exponents. That's what we did on Monday. Today we're expanding our rules of exponents. Okay, and this one is multiplying powers of the same bases. The base needs to be the same, meaning the number I am raising to a power, that needs to be the same. 3 to the 4th, 3 squared, same base, 3 and 3. Okay, so how do you do this? Well, this is not really, yes. Okay. That was a rhetorical question. So this first step, no, I'm glad. No, pleased. I'm glad that you know and are ready to share, but I didn't want to do a demonstration first before we go straight to the rule. And why the rule works the way it does. This is not how I expect you to do all of these problems. I don't want you to do this much work. But when we have 3 to the 4th, that means we have 3 times itself 4 times. And then when we have 3 squared, that's 3 times itself 2 more times. 3 squared, 3 to the 4th. That's what we're doing here. That's 3 to the 4th times 3 squared. How many 3's are we multiplying? We're multiplying 6. So this is 3 to the 6th power. What is the relationship between 4 and 2 and 6? You add them. So if I could do the same thing here, I could write x squared, x to the 7th. And so I'd have 2 x's for this and 7 x's for that. How many x's would I have all together for multiplying? I would have 9 x's. This is x to the 9th. Yeah, but so what do you think it's going to be?
Which one?
Our rule for how do you do this? Oops. Yeah. Yeah. If the bases are the same, you add the exponents. Easy. Really is. So the next one, the last example here on this page, I have 2 cubed times 2 cubed times 2. Now, when I don't put a number down for power, what do I actually have here? How was this? This is 2 to the 1st, right? So 2 cubed times 2 cubed times 2 to the 1st. That's 2 to the 7th. I do not expect you to tell me that is 128, which it is. Leave it as 2 to the 7th. Okay? If it's like 2 cubed or something like that, that's a small enough number, multiply it out. But most of these other ones, I don't want you to do it because they're too big, and that's not the idea of what we're doing here today anyways. Okay? So make sure you got the rule down. If the base is the same, you add the exponents. Can't get much easier than this. Yes? Because when I have 2 by itself, what's the power that's there? It's an unwritten power. It's what? 90% of the time, if we don't have a number written, it's 1. I should say 80% of the time. 10% of the time, it's 0. Because we don't do plus or minus 0. We add 0, we just don't write it down, right?
What about the other 10%?
When you do square roots, and that's a whole different problem altogether. You won't deal with that problem until, well, maybe a couple of years down the line. Well, the 2 kids are dealing with it now. So, but yeah, anytime we have something where there's power not written, that power is 1. Okay, that power is 1. So, just want to make sure you understood that that's where you're getting it from. Clear? Okay. It's like when we have x by itself, how many x's do we have? We have 1 x, but we don't write the 1 in front of x by itself. Okay. So, please take a moment to do the examples in problem number 1. I gave you the rule. You should be able to do those problems. In a momento. Okay, these aren't too terribly bad. 12 to the 4th times 12 cubed is 12 to the 7th. I have -5 to the -2 power, -5 to the +7 power. This would be -5 to the 5th power, because -2 plus 7 is 5. It doesn't matter what the numbers are. When you're multiplying, you add the exponents. Doesn't matter what they are. Now, this brings up a point that is extremely important. There is a difference between that and that. -5 squared and -5 squared. They are different. They are not the same thing. And it's order of operations. What is being squared? In this one, the 5 is being squared. The negative technically is not the number being squared. It's not part of it. Order of operations, I do exponents before multiplication. The negative out in front is technically multiplication. So I square first and then make it negative. This one is -25. The other one, what am I squaring? I'm squaring -5. Everything that's in the parentheses gets multiplied. So it's -5 times -5. This one is +25. There is a difference. It's an important one. The negative in front doesn't get squared unless it's in parentheses. Everything in the parentheses is getting squared. On the first one, only the 5 is getting squared, not the negative out front. Okay? And we will hit this again and again the next few lessons we have. I just want to introduce it because it is extremely important at this time. Okay. Now, the next one's a little complicated, but it's not bad. It's not bad. When I'm multiplying algebraic expressions, and when I have things in particular, some that have a power, some that do not, how I handle the multiplication is an important concept. I look at 4z to the 5th times 9z to the -12. You don't have to do this, but to help you understand how this works, remember, multiplication order doesn't matter, so I can rearrange things that are being multiplied into any order I want. And I have 2 times 3 and 3 times 2. Doesn't matter which one comes first. Doesn't matter. This is all multiplication. I can do it in any order I want. So I can rearrange this to have it be 4 times 9 times z to the 5th times z to the -12. And think about it that way. When I have numbers and variables both, the numeric portion gets multiplied like normal numeric portions. 4 times 9 is 36. Okay. The multiplication of the numbers in front just gets multiplied like normal. There's no exponents on them. There's no exponents on the numbers. You just multiply the numbers. Okay? Then you do the variable portion. Z to the 5th times z to the -12. Okay? So 5 plus -12. Z to the -7. This portion gives me this, which gives me that part of my answer. Okay? So you do the numbers out in front. The numbers get multiplied just like usual. Nothing's changed on that. 4 times 9 is 36. Doesn't matter that there's other stuff being multiplied. Just do those, and then you do the other parts. Okay, does that make sense? So if I look at the next one, well, I've got 2 times 9 times 3 just doing the numeric portion. I actually do it in any order, so I do 2 times 3, which is 6. Do 6 times 9, which is 54. So that's just the numeric portion. Now I have to do the other variables. How many types of variables do I have? I have A's and B's, right? I do all the A's, then I go through and do all the B's. So I do the A's next. And I have an A there and an A there. And this is A to what power in the front? A to the first. And A squared, so I have A to the first times A squared means I have A to what power here? To the third power, A cubed. And then I look, what do I have left? I have B to the fourth. Do I have any other B's? No. So I just kind of take the B to the fourth and move it over here, and I'm just fine. It doesn't change because there's nothing multiplied by it, so it doesn't change. Okay? Sometimes it happens with variables. You don't have any other variables, nothing happens. You just make sure they're still in your answer. Okay? Not difficult if you don't rush. The biggest mistake on these, rushing through. Okay? Questions so far? Okay. Problem number 3, multiplying with scientific notation. Multiplying with scientific notation, it's easy. Dividing with scientific notation is easy. It's the adding and subtracting that's a pain in the butt. Multiplying scientific notation really is very easy. First thing you do, multiply the two non-powers of 10. 3 times 2, 6. Times 10 to the, now I multiply the powers, 10 to the what? So I have 10 to the 7th times 10 to the 5th. What do I do to the exponents? Add them. 7 plus 5 is 12. 6, 10 to the 12th. See? Easy. So the next one. There's actually 3 steps to getting the answer on the next one. But my first step is still the same first step. Multiply the two numbers. 4 times 6. 24. Times 10. I multiply my 10s. What? 4 times 6 is 24, right? And then negative 5 plus positive 3 gives me negative 2. There's a problem with this answer, though. For those of you who remember your scientific notation, there's a problem with this answer. No, you can have negative exponents, that's fine. It just means it's a really small number. There is another problem, scientific notation. One of the rules of scientific notation is, yes, you know? You want to guess? I think you know, but you're not positive. Does that make sense? Alexis, do you know what it is? You're not allowed to have a number larger than 10 here. You're not allowed to have 24. It has to be 2.4. You can have only one number. It has to be somewhere between 1 and less than 10. You cannot have a 2-digit number. It has to have a decimal. That has to become 2.4. And then I have to change my power accordingly. So, it's been a while since I've done this one. Let's see if you make it. Yeah, I have to add 1 because I moved the decimal point from here to there, and if I move the decimal point to the left, I have to make the exponent larger. So I need to make this larger by 1, so that would be to the negative 1 power. In which case, we should not be using scientific notation anymore. You should get rid of it, but that's besides the point. You know why they use scientific notation? So you can work with really big things like astronomical distances, how far it is between us and Mars, the mass of Jupiter and things like that, because those are absolutely huge numbers. Rather than having numbers that are 20 digits long, we came up with a shorthand so we can work with them very easily, and to work with really small numbers like the mass of an atom. That's what scientific notation is all about. Really, really, really huge, giant numbers, or really, 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 really tiny numbers, and being able to work with them easily. That's why it was invented. And it really does work. And if you multiply big things, your calculator will actually automatically go to scientific notation on some of the answers for really large ones and really small ones. Okay. Now you don't have you don't have any more in your notes, but I do want to do an example to help you understand how to do your homework. Okay. So I'm going to do a sample homework problem here. Okay, so on your homework, the worksheet I'm going to give you guys here in just a few minutes, it has some problems on the back side where you're finding the area. Just find the area. And you have a triangle, which is 1/2 base times height. It has a parallelogram, and it gives you the things you need to multiply to do it. But if I want to find the area of this rectangle, here's what you do. The area of the rectangle is length times width. So it would be 2x squared times 3x squared plus 10. That's what you need to do, but you need to simplify that, which is where the stuff we learned today comes in. But that's what you do. You take one side times the other side, right? And then you do what we did today. You have to multiply 2x squared times 3x. So yeah, so your area would start out would be 2 times 3 gives me 6. X squared times x squared would be x to the 4th power, because 2 plus 2 would give you 4, right? 6x to the 4th. And then you have to do 2x times 10, or 2x squared times 10, because you have to distribute, right? Okay, we've done that. 2x squared times 10. Well, 2 times 10 gives me 20 plus 20. And then x squared times, are there any other x's here? So what do I have down here? X squared. I have to have the x squared that I started with. Everything else that's in your homework we've covered today. And I wanted to do this as an example so you knew it. Yes. No, you can't, because the powers are not the same. The powers are not the same. These are not like terms. You cannot combine them anymore. You can multiply when the powers aren't the same. You can multiply. You cannot add. To be able to add them, they have to be like terms, which means the variable and the exponent on the variable needs to be exactly the same. They both have x's, but the powers are different, so you cannot combine them again. Okay, good question. Any other questions? Cool.